Hello everybody, my name is Cleon and I am from the Digital Flight Dynamics Development and Management team. We'd like to welcome you all to a brand new development update series named Discover350 as we showcase our progress on the A350X project and show you around and familiarize you with the systems. Before we go ahead with the update, I'd like to declare a disclaimer that the models and systems showcased in this video do not indicate the final product and are only a testbed for simulation. We'd also like to disclaim that the models used throughout the video are our own developers' 3D creations and not reused from any pre-existing models. Welcome to the A350 cockpit, everybody. As you can see here, we have the base version of our primary flight display on the EFIS panel, which has been made with a high level of accuracy in mind. The screen resolution matches that of the real aircraft, along with accurate placement and colors of the various elements on the PFD, such as the flight directors, artificial horizon, speed tape, altitude tape, vertical speed indicator, flaps indicator, COG trim wheel setting, and the FMA, which we have set according to real-life references thanks to our wonderful providers team consisting of various pilots, engineers, and technicians who work with the A350. We also have the eCam display here with various different SD pages traced from the real displays, which we will showcase in later parts of the video. Let me now show you the PFD in action. First, let's set the flaps 1 setting, and accordingly, you can see the flaps indicator moving on the PFD. Now, let's turn off the parking brake and set the throttles to toga power. And for now, we can assume V1 for 140 knots, since we don't have the correct weight and balance simulated yet. Alright, now that we have taken off, you can see that the artificial horizon is displaying everything correctly, and the vertical speed indicator shows us an upward slope, which is correct, and the speed indicator increasing accordingly. Please do note that we have not implemented an accurate flight model or any fly-by-wire systems. This is not a representation of the correct handling behavior. The entirety of the PFD is custom and made using the React library in TypeScript. The FMA for now is static, as we have not set up the FCU and the auto-flight navigation systems yet. Now that we've surpassed enough speed, we can retract the flaps. And again, you can see that the flaps indicator moving accordingly. Now, let me show you some maneuvers to show you the danger zones on the artificial horizon of the PFD. As you can see, when I pitch up too high, we see the red arrows which are working correctly. This is the same on the lower side of the artificial horizon when excessive pitch down is applied. Let us now have a look at some of the progress the team has made on the eCam display.
Hey everyone, I'm the Rice Tech and I'm a part of the avionics development team here at Digital Flight Dynamics. Today, I'll be showcasing the new eCam that we've been working on for the past few months. Those of you already in our Discord server may have seen a work in progress shot of this display back in August, but it's been completely redone since then. In order to achieve true accuracy, we've used many references from the real aircraft which were provided by our awesome providers. To start things off, let's take a look at the engine display up here in the top left. All of the gauges here work as they should, displaying current engine parameters such as the thrust percentage, N1 rotational speed, and EGT, which is the exhaust gas temperature of the engine. As you can see, when I put the engines at full power, the thrust, N1 speed, and EGT increase, and these values are accurately shown on the gauges just like how they would look in the real aircraft. The thrust rating that you can see at the top of the display is currently static as we don't have a proper engine simulation just yet, but that will come in the future. In the middle section of the left side, we have the system display, which includes several different pages that represent live information about each system on board the aircraft. The page that is open right now is the Elec AC system display page. Our friend Oeid will be giving a brief explanation of how our electrical system works later in this video. Down here at the very bottom, we have the permanent data section, which includes information such as the temperatures, flight time, and weight information of the aircraft. The temperature values are working and are tied to the in-game values. If I change the temperature in the weather panel here, you can see that the values update as they should. Finally, on the right side of the ECAM is the warning display, which displays active ECAM procedures, limitations, reminders, and a lot more information regarding the Flight Warning System, or FWS. We don't have an FWS in place yet, so the entirety of this display is currently static. Now, let's move on to our progress regarding aircraft system.
Hi everyone, I'm Oeid, and I'm part of the Systems Development and Management teams. I'll be running through some of our progress on the simulation of the aircraft systems. We have elected to use the Rust language for its performance, strictness, and ergonomics. Some of you may know that fly-by-wire also uses Rust in the A350X. One of the joys of open source software is we can read through and understand how they've simulated similar systems and take inspiration for elements we think work well and adapt areas we think can be improved upon. We have also been collaborating with Synaptic Simulations, who are building the A220. For the most part, however, the vast majority of the code is written by us. At this stage, we have made good progress on the electrical system and have been finishing off the fundamental physics simulation in the hydraulic system. Unlike many other Airbus aircraft, the A350 actually has two different alternating current systems, while the A320, for example, just has a 115 volt system. The A350 has both 115 and 230 volt systems. Additionally, the A350 has variable frequency generators, meaning that its AC buses vary in frequency, unlike fixed frequency ones on the A320. Because of this greater degree of complexity, we are building a highly flexible electrical framework that allows for a realistic and granular simulation that is entirely physics-based, rather than hard-coded for specific situations. In the A350, each electrical system has two sides, which each have a generator in both engines and two batteries. The batteries are using modern lithium-ion technology, unlike most other Airbus aircraft. The generators supply the 230-volt AC system, which then supplies the 115 AC system through auto-transformer units and the 28-volt DC system through transformer rectifier units. The aircraft also has dedicated emergency power networks, which include the ram air turbine and the static inverter. We simulate all these components and more, as well as automatic reconfiguration. We've been looking at the AC and DC ELEC pages, custom written by our developers Dynamic and the Tech. In a standard situation, with all engines running, you can see that all buses are powered just fine. If we were, for example, to switch off a generator, you can see that the system automatically reconfigures itself to provide continuous power. As mentioned, at the moment, our hydraulic simulation is still in the physics simulation stage and isn't yet connected to aircraft systems. However, I'll briefly illustrate the level of detail we're capturing. The A350's hydraulic system is a complicated beast. Thus, like the electrical system, we have elected to use a highly flexible physics-based simulation that models fluid movement around the system down to the milliliter dynamically. We simulate each individual fluid chamber, pipe, and valve. Here you can see a snapshot of a small example system of fluid and pressure simulation, where the lines are pipes and the circles are chambers of fluid. This uses efficient graph network flow algorithms, so it is very fast to calculate. As an example of the level of detail in the simulation, the movement of each individual piston in the hydraulic pumps is calculated to determine precisely the volume of fluid flowing through the system. To illustrate this system at work, here's a debug rendering of a hydraulic actuator, which are used to extend things like cargo doors and landing gear. There are no special animation formulas, custom tweaked low-pass filters to emulate this movement. We purely use a physics engine and apply the forces from compression of the fluid in the actuator's two chambers. This gives highly realistic behavior, such as the wobbling, automatically. We are also using these actuators on all flight control surfaces, such as ailerons. Therefore, if a hydraulic system fails, the connected actuators would automatically stop working. This means surfaces moving at half speed when appropriate, or drooping once on the ground with all engines off. Once an API is available in the simulator, we also intend to exert aerodynamic forces on the surfaces. It's important to note that performance is a primary factor in our design. Thanks to Rust and our design choices, we are able to provide this great level of detail while also being incredibly fast to run. We also know that many people will want to fly this long-haul airliner on long routes, without the need to wait 15 hours in real time. As such, the ability to use high simulation rates is a core goal in the design of the systems. We simply can't wait to get this aircraft ready for you to fly. We'll now take a look at a small snippet of the fantastic work the team has done on the 3D modelling of the aircraft.
And with that, folks, we come to the end of the first Discover350 episode. If you would like to look at our older progress updates or have a chat with the team and hang around, you can join our Discord server, which will be linked below. If you are a 3D modeler or a programmer interested in working with us on the development of the A350X, the application form link will be posted in the description as well as on our Discord server. Thank you for watching this episode of Discover350, and we'll see you in the next one.